Assalamualaikum and hi to all. Okay, in this video, I'm going to continue our subtopic, which is subtopic 8.4 under comparing performance. In this subtopic, we will cover only a few. First is, of course, the overview or like introductions, and another one is average performance. Okay, what is the overview under our 8.4, which is comparing performance, which is normally when we heard about a word of compare, so means that we're going to compare some things with something, which is two things. We cannot compare like one things, but maybe we can also compare about one thing, but it is more like in terms of times. Maybe you compare your current laptop performance if you compare to previous time, which is the first time that you bought. So the time, but it is like too hard to compare. So that's why normally we will compare two things, two elements, two materials, and etc., which is we want to check which one is better. Macam lah you compare, if let's say there is two persons that yang want to close with you, either girls or boys, depends, and then you want to compare which one is better for you to be your girlfriend or boyfriend, which one can be your future wife or can be your future husband. So maybe that things will happen if like you really handsome or beautiful. Maybe there is several person that like you, and you was like, oh, which one I need to choose. So when you want to make a choice, same goes to whatever happen in our daily life, which is we want to choose which product is best for us, which handphone, which smartphone is best for us, whether it is Samsung or whether it is Apple. So whether you want to compare in terms of the design, maybe you can also compare between the performance itself, which is about the RAM, or maybe about the quality of the pictures, the pixels, how many zooms that can be available for both mobile phones and so on. So that is on the things that we might compare. So in this 8.4, we're going to learn about the comparing performance. So we're going to compare a performance. Compare performance assessments is a quantitative science. Mathematical and statistics tools give us many ways in which to rate the overall performance of a system and the performance of its constituent components. There are so many ways to quantify system performance. So basically, as I mentioned in the beginning of our module 8, we will look into more to mathematicals, which is we will play around with numbers. So that's why in just comparison also we're going to look into mathematics, and there is some things that related to mathematics but in terms of statistic tools. So in this kind of performance comparison, we will apply that both. In this section, we describe the most common measures of average. So we're going to average computer performance and then provide situation where the use of each is appropriate and inappropriate. Okay, in comparing the performance of two systems, So just now I share with all of you, like we want to compare between two handphone, is it? If let's say you want to compare to handphone, so you can compare it easily also, but in terms of performance, you need to compare two system. We measure the time that it take for each system to perform the same amount of work. This one also I already talked in the class. Let's say you open the YouTube when you want to buy a new phone, right? So normally there is a, apa orang nak panggil tu, video like comparing to product. Let's say before I bought my phone last time, I do survey. I did survey on YouTube, which mobile phone is better. Let's say I compare between Samsung and also Apple's at that time, and then there is a, in term of performance, when you restart the phone, which one is the most faster. Sometimes maybe you open the Google Chrome, which one is faster. When you open the game, which one is faster. So this one also, this example is in term of comparing uh, several tasks or several work, and in term of time. If same program is run, so benda yang sama, the same things, the same program. Kalau in term of you open PUBG at your Samsung and PUBG at the Apple, so which one is the fastest? So in term of time also, you will start time stamp when it's finished. So two different system, which is system A and system B. How you going to compare? System A is n time as fast as system B if running time for system B compare with the running time of system A equal to n. If let's say this one is n time faster, maksudnya lebih laju sebanyak, contohnya 2 kali ganda daripada sistem B. When you have like this, but maybe okay, let's say you have running time for B and running time for system A, your n value is 1. So if let's say n value is 1, means that A and B ni performance sama. The performance is similar, which is same fast. You can also measure it in terms of percentage. System A is X% faster than system B if you need to put running time on system B, running time on system A minus 1. And then you're going to times with 100 equal to X. This is the X, which is in terms of percentage. You want to find the percentage. If let's say okay, so this is on how you're going to measure in percentage, and this is we call it as a nispa. How many times if we compare with A and B in terms of nombor bulat, is it the integer number. Okay, let's say
It's 1 hour.
okay, let's say example 7. Consider the performance of 2 car race. Okay, I like car too, but kalau dah tua-tua ni I cannot choose anymore, because I need to like checking my own financial also, and I need to think about my kids. Kalau I still singles, betul lah single, bujang ni malah bujang. If let's say I single lah, maksudnya I didn't have kids, so of course I'm going to like also try to think about a car or any properties that I love. But now today, I don't think that I can think about that. So all of you, maybe when you look into the picture, of course, like which car that you want to choose, whether it is this red color car or maybe the yellow. Is okay, is it similar car? And then maybe a white color car and the orange color car over here. Maybe this is GT. I also don't know about the car names. So if let's say you want to buy all of this car, just assume it is a similar, not as the brand or maybe the price. Okay, maybe the price is similar. Maybe it is 1 million. Okay, maybe the price is similar. You want to buy a car with a similar price, 1 million, let's say. But of course, you want to check which car is better in terms of performance. So you need to compare. Car A complete a 10 miles run in 3 minutes. So dalam masa 3 minutes, you can reach until 10 mileage, 10 meter, let's say. And car B complete in term of 4 minutes. So how about the performance? You're going to compare how many time car A fast than B. So what you need to do is you need to compare B per A, and then you're going to have the value of n. This is the first equations here. So what you will get is 3 you will get as 4 over 3, and this is the value of n. So maybe you will get 3.33. So the car A will is much faster than car B with the value of 1.33. So in sentences, car A faster 1.33 fast rather than car B. So in terms of the percentage, what is the percentage of car A faster than car B? So what you need to do is you B over A and then minus 1, and you're going to multiple with 100 and then equal to X, similar to this equation. So you just apply in the equations. So this one, car A is 1.33 times as fast as car B. And in terms of the percentage, you're going to get 1.33 minus 1 times 100. So the percentage is 33% faster than B. Okay, that is in terms of comparison between a system. If let's say, how about the average performance? The previous formulas are useful for comparing the average performance of one system with the average performance of another. It's basically similar, only like if let's say you were given with the average, then you can compare with the average. When we evaluate system performance, we are most interested in its expected performance under a given workload. We use statistical tools. Wait. Okay. We use statistical tool forming a concise measures of central tendency. So there is a few equation you need to memorize also in terms of the average performance. First of all, you need to learn on the aromatic mean. So mean we already learned from our primary school. So last time kita also known as a average, ataupun in term of Malay, it is a purata. So kita dah tahu purata tu macam mana. Let's say purata, okay. Let's say kita berbelanja. Let's say we use our money pocket 300 per month for food. Okay, this is just example. Let's say for each month we use in 1 month, okay, in 1 month we use 300 to buy food. So how how much we spend per day in term of the average, in term of the mean. So let's say in the 1 month we have 30 days. So 300 over 30, then we will get the equal to 10 ringgit, right? So the mean or the average ataupun purata sehari kita berbelanja for food, it is RM10 ringgit. So this is just an example. So the aromatic mean is the ones with which average is most familiar. If we have n measurements and we add them together and divided by n, then the result is the aromatic means or average given by x. I think this one is x. X over n. So the aromatic mean can be misleading if the data are skewed or squared. Kalau you punya data ni ada error ke, ataupun there is something that missing in your data, so it's going to be come out as a mislead. So let's say you were given the example. So this one is tak perlu macam too complicated for you to think, because this one is more on mathematical terms. Macam you balik kepada UPSR, something like that. So consider the arithmetic average running time in seconds of 5 program. You were given V, W, X, Y, Z as the program, and 3 system A, B, C in table below. So let's say lah, kalau kita nak nampakkan dengan perkataan, let's say the program is Words, Excel, Pen, PowerPoint, apa lagi, Photoshop, let's say. And you compare with, let's say this one is Lenovo, and then this one is Acer, and this one is HP. So you want to compare the performance for these 3 laptop. Kalau if let's say they are running Words, Pen, Microsoft, PowerPoint, and then they open another Excels, and lastly the Photoshop. So this is all the time given for them to average running time. So this is the average running time for each program. So how about the average? The average, so you're going to add it all, and of course you're going to divide it with 5 program, similar to all others. But is it similar or not? The performance difference are hidden by the simple average. So this one also you can see, basically it is similar in terms of the performance if let's say the average is similar. So another example, apa yang berbeza dekat sini. Okay, there is 2 system only and you are given education. Okay, so if education frequencies, which is your expected workload, performance you yang you expected are known, and which that average can be revealed, dan dia dah bagi juga you punya average. The running time for system A, which is, let's say kita assume it as a Lenovo, and system C, which is our HP, restarted in the following table. Restated in the following table. So weightage average for system A, you going to this times with this one, because this one is execution frequency, dia dah beri you directly the value, so you need to times with 50%. 50% how much? 0.5. You're going to times with 50 if you want to calculate for system A, and then you're going to multiple with 500 if let's say you want to calculate the system C. Same goes a program W, kalau education frequency dia 0.3, you're going to times and you're going to times this if you want to calculate the C. Then after that you go do the similar thing, which is you plus all the times. Okay, now you're going to see 50 times 0.5, 200 over here times 0.3, 250 times 0.1, 400 times 0.05, and 5,000 times with 0.05. And all together you will get 380 seconds for the wastage average. Similar wastage average calculated for system C. How? Of course, it's going to be different in the execution time, as long as your similar wastage average calculated for system C. No. This one is not the value is similar, which is the way. The way you calculate is similar, and you're going to get the value of this, which is you multiple lah. 500 multiple with 0.5. This one is 600 multiple with 0.3. Over here is 500. And then add 100, and lastly 350, and you're going to get the value of 695 for system C. So when you want to compare the performance, you're going to go back to the equation previously. You're going to compare, which is if you want to compare the system A. So system A will be at the below A, and then system C minus 1, and then times with 100%, you will get in term of X in the percentage. So try to do it. You're going to get like this, similar things. Okay, however, workload can change over time. So all the workload can also be changed over time. A system optimized for one workload may perform poorly when the workload changes, as illustrated below. So mungkin as mentioned, kalau misalnya you punya komputer ni, sometimes you are using what tadi Lenovo, right? Maybe sometime it's going to be have the education frequency as 50. Maybe entah macam mana you punya performance is only 25%. So it depends. Sometimes it can be like this and then this. So you try it several times. Similar also, let's say lah, kalau you ada phone kan yang you kata you want to compare between Samsung's and also Apple. You try restart. Let's say first time you try, this one is 10 second, this one is 7 second. Maybe this one is lagi laju, Apple. This one is Samsung. and then you try to restart the second time. So maybe here is 9 second, yang ini pula dah jadi 10 second. So you try lagi, restart another time. Maybe dekat sini dia dah jadi 7 second je. Maybe kat sini pula 9 second. So that's why in reality, in our reality, which is when we did experiment, we cannot only do one time. So that's why sometimes we need to do several times. So as mentioned over here also, over here there is two kebarangkalian. There is two possibilities. Maybe at the first possibilities, or as a first time for the education frequency, this is the value. But maybe your second time, this is the value. Similar also what happened here. So there is cases, because in our real time measurements will be like banyak factors that will, there are too many factors that will affect your experiments, your value and so on. Okay, that is on the aromatics average, right? Now we're going to jump to the second, which is the geometric mean. Relative performance, also known as the geometric mean. Previous discussion cannot use the arithmetic mean if measurement exhibits a great deal of variability. Kalau there are too many, okay, kat sini yang is going to be count out. The geometric mean give us a consistent number with which to perform comparisons regardless of the distributions of the data. The geometric mean G. So you are it give you directly the value, the units is defined as n times roots of the product, which is called as xi. So xi ni x1, x2, x3, x1, x2, x3 and several, and the n measurements until of the n measurement ni selalunya dekat hujung sekali. It is not -1 because we start at the x1 and represented by the following formulas. So this is the formulas that you need to know. Unlike the arithmetic means, the geometric mean does not give us a real expectations of system performance. It serves only as a tool for comparison. So dia hanya digunakan for a comparison tools. It's just used for a comparison tools. The geometric mean is more helpful than arithmetic average when you want to compare the relative performance of two systems. The system under evaluations are normalized to the reference machines when we take the ratio of the runtime of the program on the reference machines to the runtime of the same program on the system being evaluated. So this is the next example, which is system A and system C normalized to the system B. Given the geometric mean for a samples of 5 program, still similar, you ada Excel, you ada Words, you ada Microsoft you ada PowerPoint, you ada Pen, you ada Photoshop. And found by taking the fifth roof of the product of the normalized execution time for each system. You ada 3 system. System A, which is Lenovo, system B, which is Acer, and then system C as HP. So you were given with system A execution time and execution time normalized B. You were given with system B execution time and execution time normalized B. you were given with system C education time and education time normalized B. So the normalized is now we are looking at B. Kita compare dia with the B as the normalized. So the geometric means is 1.6, 1 and 0.6. Why it 1 dekat sini? Kenapa this one is 1? Then you're going to see, because you're going to look over here. Kalau if let's say you open Microsoft Word, let's say you are taken 50 second for system A and system B 100. How many? You going to, let's say, mana yang lagi laju? Of course, this one is lagi laju. This one is much faster than B. But how much faster? It is 2 times faster rather than system B. Kalau you compare with system B dengan system B normalized, of course lah, system yang sama, it's going to become out with value of 1. Kalau you ada system B, you normalize dengan B juga. No, B is of course 100 also. 100 per 100 is going to be 1. 400 with 400 is going to be 1. Okay, we look second. Let's say we want to open Excel. Excel kita buka for system A 20 second. Kalau 20 second dekat our Excel. Excel is 400 second. Of course, this lagi cepat. Berapa banyak dia lagi cepat? When we compare, we're going to compare 4/2, right? Of course lah 400. Tapi kalau dah pandai mathematics, I think you can just remove the 0 over here. So, of course, you're going to get 2. How about this one? 250. Dia 2 times also. And the rest. Okay, then you compare dengan system C. If you compare with system C, we have kalau kita buka ada HP lagi slow, 500 second, 500 second kita baru can open your window. You tunggulah loading 500 seconds, then baru dia buka. So it's much slower than system B. How much is slower? It's going to be 100 over 500. Over 500, how much you will get? You're going to get 0.2. This one also similar. 600 dengan you compare 400. 400 over 600, you're going to get 0.6667. If let's say, yang this one is look clear, because sistem B dengan sistem C, bila you nak buka Excel, bila you buka pen, sama masa dia, the time is equal, 500 and 500 second. So that's why you will going to get normalized value as a 1, because sama. So that is how you come out with the table. Okay, so the geometric mean for system A and system B normalized to system B are calculated as follow. This one ni dia dah bagi Okay. Okay, this is the first, which is program A. Program B macam tadi Words, Excel, apa ni tadi, pen, whatever program lah you open, you compare, you will get this thing, right? Tadi you compare this one, you get this value. After you get the value of all of these, which is you going to compare. Okay, I delete first. Okay, you're going to compare 100 over 50, 400 over 200, 500 over 250, and you're going to do the factor. Ni you dah buat, and you're going to times all the value. Nilai-nilai ni, this value you're going to times all together, because you're going to look into this equation. You're going to times the value of Excel, Words, what else? Paint, Photoshops. Kalau you look into the average tadi, you akan tambah, isn't it? You're going to add all and you're going to average. You dapatlah average dia. But over here, you're going to multiple all and you're going to factorize it with the value of n. Berapa banyak program that you are running. Mana tadi? Okay. Then, you can see, you do and then you multiple it all together and you're going to factor with 5. 5 mana datang? It's going to be total program that you are running and also you are comparing with. Then you get the value. And after this, you're going to do the similar, which is you compare with the your punya HP, which is your punya C program system. You darab semua and then you're going to factorize with 5, which is 5 program, and you're going to get the value. So this is similar apa yang jadi dekat table ni, which is that I already share with all of you. Okay, now you have another example. Example 12. System A, System B, Okay, System A and System B normalize with System C. Sekarang ni dia normalize dengan System C, which is both system ni compare dengan System C. Yang tadi, which is the previous question, you normalize dengan System B. Now you normalize with System C. Apa akan jadi dekat sistem C normalized? It's going to be similar, which is 1. Because you normalize it and compare it between similar system. Yang berubah, yang the different is A and B. How you going to get the value? You're going to compare C and A. If you compare C and A, you akan dapat the value of 10. 600 dengan 200, you akan bahagi, you divide it, you akan dapat 3. 500, you divide dengan 250. This one is you compare kan, system C and A, you dapat 2. 2 times faster rather than system C. 2 times faster rather than system C for program Excel, let's say. So this is all the value, and apa yang you going to do with all this value? You're going to multiple, you're going to multiple, you're going to multiple, and you're going to factorize it with 5. Then you get this value, which is, what is the value? Geometry means. It is not arithmetic mean anymore, but it is a geometry means. You're going to do the factorize. That is only the difference between geometry means and also the arithmetic means. So this is the similar way. Sama juga dengan the example of example 12, isn't it? Example 11. Sama je, it is not very hard. And the properties, one of the nice properties of the geometric mean is that we get the same result regardless of which system we pick for a reference. If let's say you compare dengan sistem mana-mana pun, you akan dapat result yang sama. 550. Okay. So that is the things first that what is like, I guess it is more that advantages for a geometric means. Based on previous two example yang tadi, example 11 and 12, we can notice that the ratio of the geometric mean is consistent no matter which system we choose for the reference machines. Kalau you tengok the ratio, system A, system B, system C. So reference machine B and reference machine C. If you compare A and B, A dengan B, A dengan B, you're going to get 1.673, which is this part, and then you're going to over with 1. And another one is geometry A and B for reference C. You're going to compare this value with this value, you're going to get the similar value. Berapa you try to calculate, which is 1.6733 lah, of course. Dekat sini dah bahagi satu. It's directly the value. So yang ini pun you akan bahagi, you akan dapat the similar value 1.67 lebih kurang. You can see. So this is the advantages. So dia ada lagi, you can compare also CB and then reference ni you going to change the reference BC, A dengan C, you going to get the similar value. All of this is the mean by the ratio. Okay, you have the exercise. You can try to do it. Senang je. Kalau you calculate, okay, saya bagi jawapan yang paling senang. Saya buat yang sini. The rest you did. Okay, see? Saya tak payah guna calculator, saya dah dapat. Education time for normalized 2A. Tengok, saya dah dapat 1, everything. Then you did for these two table. And then you calculate lah how about you punya geometric means for both, for all the system. Saya tak nak bagi solutions. Okay. Based on the previous example, if system A has been chosen as the reference machines, prove the ratio of the geometric means are always consistent for B and C. This one is daripada yang you punya value ni. Okay lah, saya baik hati, saya dah tunjuk dah. You compare all, macam mana example tadi ni. You compare for the machines B, you dapat tak the value. So this is the questions that you need to see the ratio. But as mentioned, dia ada advantage. Tadi dia punya advantage, but there is also disadvantages using the geometric mean, which is the inherent problem with using the geometric mean to the demonstrate machine performance is that all execution time contribute equally to the result. So shorten the execution time of the small program by 10% has the same effect as shorten the execution time of the large program by 10%. You bacalah dia punya disadvantages dia. Senang je supposedly. So that is on two things, which is average means and also geometric means. That's why I mentioned that under 6.8.4 tak banyak yang you need to cover. So later on, I think another video I'm going to make it for our 8.5 under benchmarking. There is several things that you need to learn. Banyak juga. Okay, so first you're going to look overview, clock rate, MIPS, and flops. This is not a flip-flop, okay. Synthesis benchmark, spec benchmark, TCP benchmark, system simulations. So after you finish, then we're going to do the summarizations, and you're going to finish all cover for your CoA subject. So I guess we meet again in our next video for our benchmarking subtopic. Okay, thank you for watching, and please be safe, stay at home, and bye bye.